Why are you sitting at the back? Come to the front. I don't bite. Please. Yeah, just to make the session a little more engaging, I think it would be nice if you can come. And even if I did, I mean, there's a lot of space. I have to really walk that much, right? So look, the session is AI-ready data. But after the great lunch all of you had, I'm not quite sure if you are ready for the topic, right? So unless you give me a loud yes, I'm not getting started. Do I have a yes from everyone? Yes. All right, thank you. That should keep us awake for a while. Now, even if you're zoning out and if you're sitting at the front, just nod occasionally, right? Look at me as if I'm saying something profound. That should do the trick. Now, this is the agenda for today. As you look into the agenda, one of the things I can't help but recall is a book called Outliers by Mr. Malcolm Gladwell. I think you would have heard. So Mr. Gladwell talks about innate human talent in this book. And why innate human talent is not sufficient to make someone successful. He talks about ecosystem, he talks about preparation, he talks about 10,000 hours of quality training to make someone really successful. Now, we are talking about algorithms here, right, which are mimicking human intelligence. They are not very different. They also need really good data to be trained on to deliver the results that we expect them to. Our friends in Gartner, they say data is the differentiator. Algorithms are just off the shelf, including Gen AI. I can't agree more. So for a CPG client, we deployed a self-service AI as an LLM chatbot, and what we found was that people who had access to really good data could make better use of that tool. Now, of course, 10,000 hours of quality training doesn't apply for algorithms, but to make them look talented, the challenges we have to overcome, they come in various forms, and some of them are flashing on your screen right now. Data is hard to find, data is outdated or insecure, issues with data quality, access to data is difficult, assets are not reusable, absence of governance controls. How many of you have faced some data challenges in your AI projects? Would you like to raise your hands? Would you like to share?
Pretty much, it's all about access to data. So at times, the data that we are actually looking for, which we know as engineers, that this kind of data will help improve the model's efficacy. Sometimes that data is just not available into, let's say, some policies or some other requirements.
Exactly. Thanks for sharing. That's exactly one of the stories on the board. I think I saw a couple of more hands in here. Yeah, you want to go ahead, please, sir?
Parsing of the data is one of the big challenges, because if the data has a different documents, just take an example, has a different layouts.
Yeah.
Again, the same document can have 1,000 different layouts.
That's right.
Parsing that is one of the biggest challenge, and if the parsing is not good, your Gen AI will show a very bad results. Though it's improving, but still there is a far way to go. So yeah, we have faced a lot of issues. We have fine-tuned those with different models as well as MLs. But yeah, data is the gold. AI is just, model is just the driver of that. So if you don't have a good data, it is of no use.
That's right. That's right. Anyone else? Please.
So the data is in different kind of silos. It reflects the different teams that are working. There is no standard form of data, no formats, the way it's stored, nothing is clear. The access rights are different. So when you're trying to put it in a model, it's very difficult to gather the data in a form that any of the models can understand.
Thanks for sharing. Indeed. So in fact, if you are to do AI projects and if you're facing data challenges, if you were to do like a fishbone and find out the root cause, it is quite likely that you're going to hit one of these root causes, right? Now, I'm going to tell you a story. The story of a project that we did with a customer, and it was a brilliant project. We are actually filing a joint patent with the customer for the solution we built. Now, what was the solution? The customer had an oven, right? And they had a camera fitted within the oven, right? And they wanted to monitor the brownage of fries, cookies in that oven. right? And that was the modeling that we were doing, right? So of course, as you can see on the board, if the fries were underbaked, they continued on the baking line. If they were overbaked, they went to the trash line. And if they were perfectly gold, then they went to the rest line. Now guess what? What was the challenge in this project? Anybody? We didn't have enough labeled images. That was the challenge. And more than the data challenge, it became a people challenge because the experts could not agree objectively on, let's say, the level of brownage and associate that with a particular label, right? So more than a data problem, it became a people problem. Now, if you relate to what I was saying on the previous slide, the data was hard to find, and the quality of data was not good. And when we say quality of data here, we didn't have enough good quality labeled images, right? And of course, sometimes we underestimate the preparation that is necessary to have this data ready before even you go into the modeling process, right? So that's what we are going to talk about today. Now, looking into all these challenges that different customers have faced and even we have faced, we have come to define AI-ready data this way. Data that is enabling accelerated and efficient training and validation of AI models to deliver targeted outcomes by being findable, available and protected, healthy and trustworthy, accessible, interoperable and reusable, authorized and fit for use. Now, these are very standard terminologies in the industry. I'm sure these are probably not too hard to understand, hopefully. But of course, if you want me to explain, I'm happy to go through. But the golden question here is, how do we enable these outcomes? How do we deliver these outcomes, right? So definitely it's super strategic to have a solid data foundation in place, right, with AI-ready data. How many of would you agree with that? Say hi. All right? But perhaps you should change your mind. Because there's this other school of thought which says we should really take a use case-driven approach, right? So that we don't boil the ocean, so that it's not difficult to calculate the ROI on the investment required for these foundational capabilities, right? How many of you believe in that? A use case-driven approach? Great, thanks for sharing. Now, this is an eternal debate, right, between this high and the ho community, or the left hand and the right hand side on this slide. So the high community is very much focusing on the data supply. They are driven by vision, strategy, historical problems that an organization are facing, the scale of projects that they want to drive, so on and so forth. And they want to build synergistic capabilities that cater to different kinds of problems, that enables different kinds of AI projects. The people on the right, they're saying, look, I don't want to boil the ocean. I, at best, want to accumulate synergies as we go. Like I build something for my AI project that can be used, but I don't want to get in a situation where my ROI is not clear, and I don't know how much money to ask for, so on and so forth. So I will do what is required for my project. That's the right-hand side. And on this slide, you will see a number of enablers that we have called out, right, which deliver some of these outcomes that I was referring to on the previous slide. On the left-hand school of thought, people are talking about unified data view, data as a product methodology, data marketplace, data catalog, data quality and observability, and it's a long list, right? Similarly, on the right-hand side, GenAI case prompt templates, centralized feature stores, foundation models, so on and so forth, and it's a long list. Now, this is not an exhaustive list. There can be many more examples from the left and from the right, right? And each of these topics are like 1.5 or 2 hours of sessions in themselves, right? But what I'm going to do today is select a couple of them, go into some real-life case studies, and talk about these things in a bit more detail. And of course, I understand the audience is technical, so that would provide some references of technology that you can even look up offline and study more about it. Okay, any questions on this slide? Are you with me so far? Great. All right, so just one disclaimer here that, the things that I'm mentioning on the right, they are not examples of AI projects. They are examples of things we have done as part of the AI project, right? They could be something super simple compared to what we did in the AI project, but yet very powerful, yeah? So now I'm going to go into the case studies one by one. right? If there are any questions, you can ask. But let me quickly check. How many of you are still awake? Show of hands. All right, more than I expected. Thank you so much. All right, good. So case study number 1. So look at how data has evolved over the years and how data structure has evolved and how data architecture has evolved over the years, right? And of course, the data management systems have evolved, right? So companies who have been out there for quite some time, they have inherited a lot of complexity, technical debt, and more importantly, even if they have modernized their systems, their data is still in the silos. I think one of you were mentioning that, right? The data is in the silos, and we are not able to find the data that we need. And that's exactly the problem one of our customers faced, right? Making data findable and accessible. Data search costs were super high. If they wanted their data scientists, if they wanted their analysts to go and find data, it was extremely difficult, right? And doing AI projects was super hard, right? Because they had to first find out where the data is, getting access to the data, so on and so forth. So what we did was to introduce the discipline of metadata management, right? So it's hard work, right? Of course, there are tools like data catalogs, and some of the examples you see on the board, like Microsoft Purview, Alation, Atlan, Colibra, and if you're in the Databricks ecosystem, you can use Unity Catalog for that. But you have to use these data catalogs to harvest the metadata and then curate them, right? You have to understand what are the business glossaries, how are they associated with the different data sets, how do you describe the data sets, how are the data set attributes described, what's the lineage, how the data flows from one stage to the other, how is everything connected, what's the active metadata, what's the operational metadata, what's the status of the data, who owns this data. Now, if you gather all this metadata, the data catalog helps you search through all of that, and you can find your data assets pretty quickly. But there's a twist. Of course, the customer rolled out data catalog, but what we figured is that the adoption of the catalog was not very high, especially amongst the persona who were not working with the data very closely, like, let's say, a data engineer or a data analyst, right? Sometimes the data catalogs could be a little technical for certain personas in the organization, right? And that is where we introduced the concept of a data marketplace, right? On top of the metadata that we are collecting, we deploy the data marketplace. Data marketplace packages the information, and this is an interesting app which is on MS Teams. Now, most of the organization are on MS Teams. Doesn't require special training now because you are so much used to the interface. So if an app is there on MS Teams, right, we don't need to give any extra training to the people who would like to search and know about the data. They can easily search, look up information about the data sets, data products, understand who the owners are, understand the metadata associated to the data, so on and so forth. They can even figure out, as you can see in the picture, they can even see some trainings. I think the picture is not that great, but there are some trainings which you can even suggest for the data products, right? Improves the data literacy in the organization as well. You can even see what is the health of the data. You can provide feedback on the data. You can request access. All of these things on an MS Teams app without additional training. And what that did was unleash data democratization in the organization, data literacy, and the assets became super findable and accessible within the organization, right? I'll pause here. That's sort of case study number 1. Any questions on this particular slide? So rather than big, it's more like scattered, right? How many systems we had. Like, there are things like on the Databricks ecosystem, there were things on SharePoint, there were unstructured data, there was data lakes on Azure Data Lake, right? It was all fragmented, right? And it could be petabytes of information, but it's all, even if it's a small SharePoint in one corner, and if someone has done something interesting out there, you need those assets to be findable so that they can be used by another person, right? So that is where these tools and these techniques become extremely useful. And also, I think with metadata, you lead to better classification of the assets, right? Sometimes if it's sensitive data, right, you want to be careful how they are used, right? Well, great question. I was hoping that will come later. Yes. especially for unstructured data. Now you asked that question. So we created something called the Intelligent Report Catalog. And this was primarily for the dashboards. And what happened is, especially when you're doing a migration or, if you want to look up what dashboards exist in the organization, but people don't document their dashboards that well. There's no like a proper discipline. So we used OpenAI to actually take the images of the dashboards and put into one place and generate metadata of those images. And of course, that could be curated further if you'd like, but just having simply the metadata and making it accessible made the dashboard much more discoverable, right? And of course, that can not only help with just finding the dashboard, but also with things like migration, right? If you want to really figure out how many reports exist in your organization, what they're doing, what do you need to do to rationalize them before you move into another platform. So those are the techniques that you can do. So that's AI for data, not just data for AI, right? Okay, thanks for that question. So moving on, case study number 2. So this is about the second outcome, achieving healthy and trustworthy data, right? So again, one of our CPG customers, the customer wanted to do data analytics on consumer data. Consumer analytics, basically, as you can see on the board, we're talking about classification of consumer behavior and so on and so forth. But there were challenges like there were duplicates, email addresses were not there, names were not properly filled in, were not complete, there were missing values. So we sat with the customer, we did a data quality assessment, figured out what the data quality issues are, we prioritized them, and according to the business impact that they're having, and the customers got a data quality baseline, like this is how you are with all these data assets. But data quality is not a one-time exercise, right? We had to introduce a data quality monitoring process. It is one thing to understand at one point in time that these are your issues and going back and fixing the root causes. It's the other thing that whether those root causes are repeatedly getting addressed, right? Or there are some new root causes emerging. This is where we deployed our bespoke data quality monitoring solution using our own framework, right? So this solution was built on Google Cloud using Dataplex, BigQuery, Composer, CloudDQ, and you have a list out there. And what we did is along with that, we created the data quality monitoring process in the organization, which led to this activation of a data quality cycle. And over a period of time, the quality of the assets improved, right? Just to show you an example, this is how the dashboard looks, right? So we are reporting against different data quality dimensions. So you actually see how your entities, how your data assets are scoring with respect to different data quality dimensions. What's the overall score of the asset? If the score is dipping or not, if it's dipping, why it is dipping, which data quality checks are getting impacted, and how do you go about checking those? Any questions so far? Please go on.
How do you define these metrics? Are there industry standards or say completeness?
Yes. So some of these there are like standard set of metrics. Like if you are working with some bespoke tools, which I'll show you on the next slide, you will get a standard set of checks that you can do against each of these dimensions, right? But when you're working on the project, that is why you need a data quality expert who can understand the business problems and suggest new rules. And that's why you create custom rules. And since this solution was bespoke, we pretty much built the entire DQ check library on our own, right, based on our framework. So we do have a common set of standard checks that we do against each of these dimensions. But again, I mean, it also depends on the customer. Typically, these 5 to 6 dimensions are pretty common. Like in the industry, there are some people who are talking about 12 or 24 dimensions, depending on whether you're following Dong Wang or Thomas Redman, right? So there are different frameworks in the industry, and the things that you measure are also a little different, right? But these are pretty popular. The 5 ones that mention timeliness, completeness, validity, accuracy, and consistency, right? Please go on. Yeah, so for data accuracy, we are typically referring to some reference or master data, just to validating that, whether it's accurate per the records that we already have. For consistency, you are just checking, how consistent the data is based on the previous refresh. So there could be different checks that you can do with respect to consistency on that, right? Or, if you are not checking conformity, you can also check some rules like whether it's consistent to the specification that you have, right? It also depends on the customers a little bit, right? How we package for one customer to the other might be a little different. So, but those are the things. But typically, for accuracy, you need some kind of a reference. Please.
How easy was it to add or modify a metric in this kind of a model? Because that's usually the case that the moment you launch it, then the very next day you can
Yeah.
some change.
Yeah. So what we did with the data quality checks, our quality checks in our framework, and different tools do this in a different way. These are pretty much configurable. So we have a library of checks. And just like you have a medallion architecture for, let's say, your data pipelines, we have the same for our DQ pipelines, right? So we scan, so using those list of checks that you have configured, you scan your batch-loaded or real-time assets, right? And then you put the scores, right, in your silver layer. And if you want the scores further aggregated, then you do put it on the next layer. So there are standard data models for, let's say, I'm probably telling you a lot. But anyways, there are standard data models for the gold as well as the silver layer. But again, the checks are configurable. You can write simple regex expressions or simple SQL queries depending on what you do. And then you can configure that way. And all the job needs to do is to run those rules, right? So pretty much you can modify anytime. So could you repeat your question? I couldn't.
Whenever you are talking about the data quality check, the data quality check you are doing just at the derivative or it's BDQ also, like the business data quality check also?
Yeah, you can pretty much configure at what level you want to have the aggregation, right? If you want to do at the data table level or you want to do at the entity level, right? Or for a subject area, you want to have an overall score. That's where the aggregation is important in the golden rare, right? And you can do the slicing and dicing. You can configure this report, right? Accordingly. This one is rule-based, but you can also use AI to generate the rules, right? If you give the context, etc., so you can use AI. So in our framework, in our roadmap, that's what we are working on right now, using AI to actually generate and configure the rules so that, even if you are not good with regex expression or, writing a SQL script, I think you can generate the rules just by using natural language. Yeah. Okay, so these are examples of some other tools which you'd like to look up. We also work with, let's say, Colibra. It has a fantastic data quality module, great expectations where you can configure the rules and, the dashboards. And Axel Data and Anomallo are more like data observability tools where you're not only just monitoring your data, but your data pipelines, your compute, usage, costs, so on and so forth. So the scope might be a bit bigger. But there are many other tools in the market. I just wanted to give you some references so that you can look up offline. It's not that we are kind of over-inclined to sell these type of technologies, but this being a tech conference, thought that suggesting some tech stack that you would like to explore would be a good idea. Okay? Great. So case study number 3. Before I go into the details, look into the board and tell me what all these cars have in common. Anyone? Sorry, white color. Any other guesses? 4 wheels. Good observation. Any other question? Sorry, what was that? Okay, I'll reveal the secret. They also have something in common called the platform, the Volkswagen MQB platform, right? And many car manufacturers are using this approach to build reusable platforms that you use in different models. Now, why I'm saying this? We are just talking about AI-ready data. From where did cars come, right? So this is in the context of feature stores, right? Which is something you build for one AI project, one model, and then you can use repeatedly in other projects. Right? So what are feature stores? Feature stores obviously store for features, but typically used in online prediction. For example, you are doing fraud detection and you want to qualify a particular customer transaction, and you can't do that real quick unless your features are pre-processed and prepared, right? So what happens in a feature store, right? So let's say for a customer, you want to create features on their activity, spend patterns, income, and keep those features pre-processed. And whenever the transaction is happening, you join on a customer ID, and then you are making a prediction or recommendation or qualification of the transaction, right? But the interesting thing about feature store is once you have created that, you can even use those features to train models in other projects, and that's how it becomes usable, reusable, right? And that is the thing on the right. If you remember on the right, I was showing in the whole community, there are a bunch of things that you can do for a project, but you accumulate synergies in the way. This is the way you can do it, right? And in this example, we were building these feature stores for 28 markets using Databricks, but there are a bunch of other technologies, as you can see on the screen, which you can also use, like Vertex AI or Azure Machine Learning, Python SDK, or some open source solutions like Feast. Yeah? So that's the reusability aspect, right? And with that, I can now go into the next interesting section. And I was told by my nasscom friends that there's some interest in this section, and that's about synthetic data, right? Now, what is synthetic data? Let's come on the same page. This is not our definition. This is a definition on the web, but just I want to put it there on the screen so that we are on the same page. Synthetic data is artificially generated data that mirrors the statistical properties of real world, but doesn't contain any real world individual's information. It's created using algorithms and simulations, often employing generative AI techniques. Yeah? Now, what I'm going to tell you is when do you use synthetic data? And how does that help you in the context of healthy and trustworthy data? So hang on in there for that particular part, right? So when you do not have data, or you do not have enough data, or your data is very expensive to acquire, you can think about using synthetic data to train your models, to enhance performance of your models, to be more cost-effective, or for rapid prototyping, right? There could be some other scenarios like, your data is scattered, or, your data is sensitive. But in those scenarios, there are other approaches of dealing with synthetic data. Dealing with that problem rather than using synthetic data. So just to watch out there, right? But typically, the more popular scenarios is when you're not having enough data or data is expensive. And we typically subscribe to 3 methodologies of getting synthetic data. One is our data scientists call them Webley data, which is, you are acquiring the data from the internet, right? Relatively inexpensive, right? And the second is augmentation, where you are increasing the size of your data sets by doing some changes, transformations to your existing data set. And we'll have some examples we'll talk about. And then, of course, foundational models, right? You provide some rules, and based on that, you generate, the synthetic data. The interesting part here is that some people even want to use the foundational models to create a program, which can be used to generate synthetic data. Why they do so? For example, if you want millions of structured tabular records, it might not be super efficient to just give the instruction to the LLM and try to get it from your foundational model, right? So that's where, creating a program through a foundational model and then using the program might be a more smarter move, yeah? Now, on Webley data, let me give you a quick example. I wanted to give you a real case study, and if you're interested, I can talk through, but this is an example I wanted to provide because this is publicly available. So one of our data scientists, Dominic, actually published a paper where he talked about how he used synthetic data, right? Especially Webley data, right? So Dominic is basically using for a problem like he wants to identify a place or a dish using a model, right? And what he showed that if you are using, let's say, 100,000 images randomly acquired from the internet, not even, well annotated, versus 1,000, let's say, accurately annotated images by humans, the performance of the model trained is much higher with Webley data with 100,000 images, right, rather than well-curated images, right? And of course, this is not a real case study, but we have used even Webley data in real case studies. Yeah. Now, that takes me to the next example of augmentation. It's a real case study, right? Although I have used images from our brand guidelines here rather than the customers, because that's sensitive. Now, in here, what we tried to do, the customer wanted to build a brand audit tool, right? So what is a brand audit tool? So whatever content or images they are publishing through social media or internet, they wanted to see whether they are adhering to some brand guidelines, right? Their brand guidelines. And we were given the task to not only build the brand audit dashboard, but also the model which goes and detects these problems in their published content, right? But how can you do that? They didn't have enough images, right, to really, especially those images with those problems which the brand guidelines were asking to avoid, right? So what we did there is to really use the augmentation technique, and there are libraries like augmentation libraries or ImageAug, right? So you can use this. It's a very simple technique, but yet powerful. So you take an existing image, and you are scaling it, introducing noise or hue, or copying it, or resizing it, so on and so forth, and increasing the size of your data sets. So, and then using those increased volume of data sets to train your model so that your model is now equipped to detect these problems in the real life, in the real world, right? And that's about, augmentation. I'll pause here, see if any questions, or if you want me to give you a few more examples of case studies, I'm happy to do so before I move on to the next slide. Okay, please.
So how did you prevent overfitting here? Like, for example, even I augment the data,
Yeah.
still some of the features will remain same, right?
Yeah.
How will I survive?
Yeah. Unfortunately, you have to go through the modeling process. It's a sort of iterative process. Maybe the data scientists will give you a more proper technical answer, but they have to go through it to understand what errors they are getting, how much you're underfitting, overfitting, what's the bias, and what's the variance, right?
For images, I think I can understand all these things, but
Yeah.
for tabular data, like,
Yeah, so you have to go through that process to some extent to actually check those errors.
what augmentation techniques did you use on tabular data?
So yeah, so that's on the next slide. So I can tell you about that. But by the way, I mean, even augmentation, there are 3 types of augmentation, right? So the first is very rule-based, where you're using the simple rules like, what I told. The second is an interpolation technique. An interpolation technique, you are mixing data sets, right? For example, if you're working with images, let's say you cut out a patch of an image and place on another image, right? And this is to mimic, say, situations like partial occlusion, right? For example, you want to detect a person, right? But the person is, let's say, moving through the chairs and the pillars, right? And you still want to find out that that's a human being, right? To do that, and when you train that, you use the interpolation techniques to mix those images. A case study here would be, for example, we did a project where we had to find out how much time is spent on doing dishes with a customer, again CPG, and for that we had to monitor the hands, right? And how do you do that, right? The hands are within the dishes, going into the sink, and so on and so forth. So for that, this technique was extremely useful. And then other is like you can use model-based techniques, to generate synthetic data. To your question, so there are some examples of how you do structured synthetic data, right? So this is a package, do-why package. You can basically create a structural causal model using this package. For example, if you have an output and there are a bunch of variables, how those variables are influencing their output, how the variables are interlinked, you can all model that using a directed acyclic graph. And using that DAG, you can then simulate and generate your synthetic data, all in tabular format. Next, similar example on structured data, LangChain synthetic data generator, then Gradle.ai, you can do structure as well as text, right? And there are some other open source libraries, Faker, Synthetic Data Vault, or SDV, and Databricks DBL Data Gen. Look, I came prepared for your question. All right, good. So I hope we have some time left, but I hope you are having some key takeaways from the presentation so far. If you at least have one key takeaway, I would consider it a success, but it's a post-lunch session, I understand. So if there are more than one, then it's a miracle, right? So I'm now moving on to my last case study. And this is about delivering authorized and fit-for-use data, right? And this is where I talk about data product operating model, right? So especially if in your organization, if you have critical data assets, right, and business needs them recurringly, and data is valuable, you want to have more focus on those data assets. So all these enablers, different enablers that we talked about, left and right hand, right? So how you deploy them for this particular data asset, and how do you make sure that this data is AI ready? So for that, you bring in the product management rigor in building these data products, right? Dedicated teams which are focused on that, dedicated investment, having a roadmap, right, on which your data leadership is aligned, so on and so forth, right? Now, on the right, if you see, you're right, right? Yeah, right? You see there's a schematic diagram, right, which talks about different data products in different domains, right? And this is very domain-driven approach, right? So you have to have a lot of buy-in from your domains, your business. They need to be involved in this journey of building data products. And you could have centralized focus teams. You may also have enabling teams which are shared among the data product teams. Designs may differ from organization to organization, but pretty much you can have cross-domain governance. And finally, when these data products are created and published, they can be available to the data marketplace. Remember the case study one I talked about, data marketplace? A similar data marketplace can be used to publish all these data products that the data product organizations are building. Look, this was my last case study, but before I wrap up, I would like to say that even beyond getting your data ready, there are many other factors involved to get your organization AI ready, right? So, and if you're interested, of course, stay in touch with us, connect to our webinars, tune into our webinars to learn more. But with that message, I would really like to wrap up here. Thanks for being a lovely audience. Thanks, NASScom.